beautiful little problem is from an Indian Olympiad. It's the pre-regional math Olympiad, and it deals with a funny looking equation: x square minus 7 times box x plus 5 equal to 0. Naturally, we are curious that what this box x is. What does this mean? Well, it is sometimes called the greatest integer function. So this does a very simple thing. If you give it an integer, let's say 2.3, it will, if you do the box of it, it will give the greatest integer smaller than 2.3. So that's 2. In fact, box of 2.99 will also be 2. Remember, we want the greatest integer smaller than the number concerned. Okay, smaller than this number. Okay, just a quick example for negatives. If you do box of negative 2.3, that will be negative 3. Why? Because that's the greatest integer smaller than negative 2.3. So this is a place where you have to be a little careful. It doesn't work the same way for positive and negative numbers, at least visually not. Of course, the meaning is same, and if you think carefully, that's exactly what you'll get. Negative 2.3, if you box it out, you will get negative 3, which is the greatest integer smaller than negative 2.3. Okay, so this is what this box function means, and what we are required to do here is find the sum of squares of the roots of the equation, this funny looking equation. And first thing that we realize is that it's hard to solve this equation in a direct manner, like using the tools that we have learned in quadratic equations. In fact, a general strategy, and this is something that you will use even in other problems involving box of x, is write x as sum of the integer part and the fraction part. So let me write it down: integer part and the fraction part. So every number has an integer part and a fraction part, and in the problems involving box of x, it is sometimes useful to write them down separately. In fact, let's write 2.3 as integer part and fraction part, and negative 2.3 is integer part plus fraction part. So this fraction part is always greater than or equal to 0. That's how we style the number. In fact, if x is an integer, let's say 5, then the fraction part will be 0. Part is 0. Okay, so we understand what this integer part and fraction part business is, and sometimes it is useful to split the number x in this integer part and fraction part. Not in this problem. This problem can be solved in a much more simpler manner. So this is just a problem solving strategy for some other problems that you might try using box function. Okay, so we want to find out the sum of the squares of the roots of this equation. So if x1, x2, these are the roots of this equation, then we want to find out x1 square plus x2 square and so on. So how do we find that? How do we find the sum of the squares of the roots of this equation? When we make a very simple observation, we see that x square, that is, if I bring the box part and 5 to the other side, we see that x square is equal to 7 times box x minus 5. So x square is in fact an integer. Use this particular idea as a hint and try to finish up this problem, and link in the description will take you to the next video, which is the second part of this problem. But before you go to the second part or look at the hints, think about this. You already have the value of the square of the number which satisfies this equation. After all, if alpha is such a number which satisfies this equation, then alpha square is 7 times box of alpha minus 5. So you already know something about the square quantity which is in the root of this equation, which is of the root of this equation. So think about it, take it as a hint, and then come back to the second part of this video. A link in the description will take you there. All the best.